Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syakir Aiman by Ariffin. My machine number is B0820102028. And this is my group mate, Nik Shahirul Akma bin Muhammad Yusoff. The machine number is B0820101066. Today I will present to you about Lab 4 Introduction to 68K Simulator. The objective for this lab is to write a 68K assembly language programming to execute basic device based on data transfer and arithmetic instructions. To become familiar using simulation software for 68K. To implement a simple application based on simulation.
Assalamualaikum. I'm Nik Shahirul Akma. I will be explaining about the program and the coding. This is for the first part. The coding is already written. We got this from the lab sheet. For the first step, we go to the project and assemble the source. Here we see we have no warnings or error. Then we execute it. Next, this window will pop out, and here we can see the program counter, address register and data registers, and we can run the program, and the output window will pop up. It says hello world. For the second part, we need to change the coding. We got this coding from the lab sheet. We need to erase this line and change it. Next, for the and the same step, we go to the project, assemble the source and execute it, and we run the program. The output is hello FTK student and new line, microprocessor technology 68K. And lastly, for the last part, we add some new line, and we can assemble the source and execute it. We can see the output here. Here we learn how to write multiple lines in one dc.b statement. Here we can see which is this one, dc.b in one sentence, and we have a new line instruction. And just remember, here we can see this line where the coding is in one line but the output is two lines. We are using this compiler. We also can see how the compiler execute the program step by step. First, we need to rewind this program. Using this step over, we can see the execute program step by step, and we can see here the program counter is 1000, because here we set it this 100, and the dollar symbol is actually we use hexadecimal data. And here we can see this, we click the step over. Before this, we rewind and we see here the program counter is 1000, and all this register is still 000. Next, we start over, and we can see this PC counter already changing to 1006 and register A1 1010. Here, because the 1006 is because each 2 bytes here represent one address. here if we see this, we have 43 F9 00001010, and if we calculate it, we have 6 1 2 3 4 5 6, and that's why the next counter is 1006, and the register A1 because here it's 0001010, and then we can start over. We can see the 0 is 000E because this hash 14 it is quick data, instant data. 14 is E in hexadecimal, and trap is actually for display message here. Next, the semi-halt, the program is, the simulator is halt, and then the output window will pop out. We also can view the memory window. Here in memory window we can expect the address, and this number actually the ASCII code in hexadecimal for each character of our strings.
In the report, explain what happens when you execute your code in step 15. Step 15. This is step 15. So, after the code in step 15 is executed, the output display hello Africa student and microprocessor technology 68K into different lines. The code of CRSLF is the instruction to create new line. Observe and show the output of the program. Okay, this is the output. Observe, assemble and run your program, and observe and show the output of the program. So this is the output. This is the program. The label of CR and LF is being used several times in the program. Explain what are these label functions. CR and LF in this program are actually constants that is linked to this symbol and this symbol. CR stands for create, carriage, return, and LF stands for line. These two instructions are used to create a line. Explain briefly the operation of the following instruction. LE, load of the effective address into the specific address register. All 32 bytes of the address register are affected by this instruction. Syntax LE and move.b. Move the data at the source to the destination location. Size is 5. That to run simulator I/O routine tasks that are built into the SIM60K simulator. DC.b. Define question byte that the tag string is enclosed in single quote. EQU. Link a label to a value similar to defining a constant. In this lab, the discussion that we made is in this lab session, we are introduced to 60K assembly language program development process using AV60K suite. We are given simple example to learn how to write 60K assembly language program, run the program, and observe the state of the register after the execution of each instruction. Using these compliance simulator help us to understand about how the address in the program work and how the program start of as executing the program. We also gain knowledge of some machine code or print and symbol that is used with TSK assembly language. In conclusion, we are able to write TSK assembly language program to execute basic device based on data transfer and arithmetic instructions and become familiar in using simulation software for TSK. We are also able to implement a simple application based on simulation. That's all for me. Thank you.